Empirical rule, another term for 68, 95, and 99 points. Objectives: to explain on how to construct empirical rule, to cite an example of how to apply empirical rule in real life. Empirical rule. The empirical rule is also referred to as the 3 sigma rule or the 68, 95, and 99.7 rule because of within the first standard deviation from the mean, 68% of all data rest. 95% of all data will follow the 2 standard deviation. Nearly all data, 99.7, fall within the 3 standard deviation. That 0.3% that remains is used to account for outliers, which exist in almost every dataset. In this lesson, you should prepare for a paper, ruler and pencil, and color. You should prepare for a scientific calculator. You should prepare for Z-table value, complete as a positive and negative. Always use the Z-table. Standard normal distribution. Table values represent area to the left of the z-score. How to draw the empirical rule. So first, draw the x and y axis. You have the 0, positive 1, positive 2, positive 3, negative 1, negative 2, negative 3. In 68.3%, we have the 34.1 and 34.1. And then negative 2 and positive 2, 95.4%. So 95.4, we have 13.6 and 13.6. And then negative 3 and positive 3 falls the 99.7%. And then we have the 0.15 and 0.15. Explanation in empirical rule. So again, how do we get the 34.1%, 13.6, 2.1, and 0.15? Again, negative 1 to positive 1 is 68.3%. So 68 divided by 68.3% divided by 2 is 34.1. That's why it's 34.1 and 34.1. 95.4% minus 68.3. So the answer is 13.6. So 13.6 and the other one is 13.6. So negative 3 and then positive 3 is 99.7. 99.7 minus 95.4 is equals to 4.3. But 4.3 divided by 2 is 2.1%. So we have the 2.1% here and the 2.1% here. So 100 minus 99.7 is equals to 0.3. And then 0.3 divided by 2 is 0.15. So again, where do we get the 100? The total area of the curve is 100. Again, 0.50 and 0.50 is 100. So 100 subtracted from the last 99.7, the answer is 0.3. But 0.3, to get the right tail and left tail divided by 2, so we have the 0.15 here and the 0.15 on the other side. So we have the empirical rule. Again, mean, mean plus 1 standard deviation, mean plus 2 standard deviation, mean plus 3 standard deviation, mean minus 1 standard deviation, mean minus 2 standard deviation, mean minus 3 standard deviation. We have the 0.15, 2.35, 13.5, 34%, 34%, 13.5, 2.35 plus 0.15 is equals to 100. Take note. If you will add 0.15 plus 2.35 plus 13.5 plus 34%, 34%, 13.5, 2.35, 0.15 with a total of 100%. Okay, so how do we explain this one as the empirical rule? Explanation, we have mean and the standard deviation. Mean is equals to 20 and the standard deviation 5. So in the center, the mean is 20. We will write the mean here in 20 and the standard deviation of 5. The very first technique here is to add in the right side and then subtract on the left side. 20 plus 5, 20 plus 5, 25. 25 minus 5, 25 plus 5 will be 30. I repeat, 20 plus 5, 25. 25 plus 5 is 30. 30 plus 5 will be 35. 20 minus 5 will be 15. 15 minus 5 will be 10. 10 minus 5 will be 5. So mean plus the standard deviation, mean plus 1 standard deviation, mean plus 2 standard deviation, mean plus 3 standard deviation, mean minus 1 standard deviation, mean minus 2 standard deviation, and then mean minus 3 standard deviation. So 20 plus 5 will be 25, 20 plus 10 will be 30, 20 plus 15 will be 35. This is in for the right side. 20 minus 5 will be 15, and then 20 minus 10 will be 10, and then 20 minus 15 will be 5. This is on the left side. Given, if the mean is 40 with a standard deviation of 10, find the percentage below 20 and find percentage 60 and above. So it means to say, if we have 40, we will write 40 here. And the standard deviation of 10, 40 plus 10 will be 50. 50 plus 10 will be 60. 60 plus 10 will be 70. 40 plus 10, or 40 minus 10 will be 30. 30 minus 10 will be 20. 20 minus 10 is 10. Percentage below 20, we have below 20, so Z less than negative 2 equals 20 belongs to the negative 2. Take note, negative 2 below. On the C table value, again, we will use the C table value. So the answer is 0.2275. So we will move to decimal places. The answer is 2.2075. 60 and above. 60 and above always on the right. Take note, on the right. So we will shade here on the right. So Z greater than 2. So again, in the whole area, if it's always in the right, 1 minus 0.97725. So 1 minus 0.97725. The answer is 0.22725. Or move, take note, get the table value of 2 in the left curve and then subtract from the 1. Take note of 100 or 1 minus 0.97725. The answer is 2.2075. M106 has an average of 80 with a standard deviation of 5. Find the percentage of the average of 96 and above. Next, find the percentage lower than 72. So again, the average is 80. First, we will draw the x and y axis. 0, positive 1, positive 2, positive 3. Negative 1, negative 2, negative 3, and we will draw the bell-shaped curve. 80 plus 5, 85. 85 plus 5, 90. 90 plus 5, 95. 80 minus 5 will be 75. 75 minus 5 will be 70. And then 70 minus 65 will be 70 minus 5 will be 65. I repeat, 80 minus 5 will be 75. 75 minus 5 will be 70. 70 minus 5 will be 65. So we will get the percentage and average of 96 and above. So this is 95. So we have 96 here, 97, 98, 99, 100. So 96, it's fall on 3.10. Z greater than 3.88. Now guys, at 3.10. Again, 1 minus the table value of 3.10 is 0.993. So 1 minus 0.993, the answer is 0.07%. Next, 72. 75, 19 to 39 years old. Find below 15 years old and higher than 59. So first, we will draw the bell-shaped curve. So we have the 0, 1, 2, and 3. And then negative 1, negative 2, and then negative 3. So first, we will find for the age of 35 with the standard deviation of 8. 35 plus 8, 43. 43 plus 8, 51. 51 plus 8, 59. 35 minus 8, 27. 27 minus 8 will be 19. And then 19 minus 8 will be 11. So, find in between 19 to 39. Take note, 19 to 39 years old. These are the pregnancy women who are not risk to get pregnant. This is a very safe age, 19 to 39. So again, this is 0.65 between 0 to 1. 0.65. See, less than 0.65. The answer is 0.74215. I repeat, this is point and then 0.65. So 0.65, 74.215. The other one is point. So the other one is 19 around 2. So 2, 0.2, 0.22725. 0.2275 for z less than negative 0.2275. Subtract 7.74215 from 74215 minus 0.2775. The answer is 0.5144 or 51.44%. So the answer is around 0.5144 or 51.44%. 0.51. And then, if the age is 15 below, take note, 15 below are very risk. And 59 above, a pregnancy woman is also a very risk. So, Z less than 2.6. This is around 2.6. Take note, guys. This is 2.6. This is 2.6. 0.0046. 2.6 in the table value is 0.046. And then C 3.0. So 3, a value of 0.9986. So I repeat, if C less than negative 2.0046, in the table value of negative 2.6, take note, table value of negative 2.6. So this is 2. This is 15. Take note, if we are fine below 15 years old, below 15, 14, 11, 15, 14, 11, up to 9. This is very risk. 59 and above, very risk. So this is around negative 2.6 in this area, shaded. So we have 0.46. These are called pregnancy teenage woman. Okay, so this one will be Z greater than 3. So the value of 3 is 1.9986. And then the answer is 0.00135 or 0.13536. So I repeat, around around 0.3995. So this is already the next problem or the last problem. Okay, suppose bowling scores are normally distributed with a mean of 30 and a standard deviation of 5. Find the percentage of games with a score of 20 or higher. So again, 30 and the standard deviation of 5, 30 plus 5, 35, 85 plus 5, 40, 40 plus 5, 45, 30 minus 5, 25, 20 minus 5, 20, 20 minus 5, 15. So again, so Z, this will be the score 20. So 20 up to 45. So Z, again, Z, negative 2.2. So 1 minus 0.27. So subtract from the left table. If it's going to the higher score, 1 minus, or going to the right, shaded to the right, it's 1 minus 2275. So the answer is 0.9775 or around 95%. So the shaded here is 97.5. 1 minus 0.02257 is 97.75. So that's all, folks.